Hello everyone. Today our first speaker of the day is Tom Ralston.
Hi, and welcome to our presentation on realizing the value of digitalization for oil and gas production. I'm the lead for digital process engineering with MySep, as Alex said, so this is really at the heart of what I do. So I'm going to outline what we're going to cover. I'll talk about production constraints and separation, and I'll focus in on an example which shows the challenge of optimizing production of a facility, which is of modest scale. How do we get rigorous separation into a digital twin? That's really, I'll show, at the heart of this challenge. And I'll show how we can reveal the real production constraints and how our digital twin can help us optimize to mitigate the constraints and hence increase production, increase revenue and margin. Finally, I'll try and summarize the value of what we've revealed. So why can't facilities produce more? Across the globe, our customers are trying to produce more on existing facilities. In the US Permian, in the Gulf of Mexico, North Sea Basin, Middle East and Southeast Asia, they're deploying production digital twins to explore, for example, tiebacks to new wells and other strategies. More often than not, a key constraint will be separation capacity. The capacity to separate gas from liquid and liquid from liquid within the facilities. So what I'd say is that separation is the kind of beating heart of the production process. On a typical mid-scale FPSO, you can see the prominence of separation vessels, and this is just some of them, for various two-phase and three-phase separation services. So really, the key production task is to separate and prepare the hydrocarbons for export from the facility. We've got to separate the gas from the liquids. We've got to separate the oil from the water. We might need a number of stages. The bounty of the hydrocarbons that we have holds within them one of nature's surprises. It's quite hard to separate with 100% efficiency. Here, the issue is mist. I'm going to focus on that. The liquid that's entrained as droplets within the gas that may well be transmitted through our separation device and on into the process. MySep's rigorous calculations start by predicting the mist fraction and the droplet size distribution in the inlet pipework system, and then proceeds incrementally with separation efficiencies for inlet devices, gravity section, demisting devices, finally predicting the outlet mist fraction and droplet size distribution. So let's consider a facility. In the process flow diagram here, if you can see this small size, there's first stage separation. There's two stages of compression, and this might be in parallel trains. In fact, there were two parallel trains in this facility. And then on this particular facility, we've got turbo expansion and low temperature separation to remove the natural gas liquids and to control the hydrocarbon dew point at the export gas compressor discharge. So up here, we want to control the hydrocarbon dew point. So with that in mind, Can we increase production? Presently, on this facility, we're producing 74,000 barrels a day of oil and 79 million standard cubic feet per day of gas. The production revenue is calculated at around $6.5 million a day. If we can make more money, of course, we'd like to do so. To optimize, like many of the customers I mentioned, we deploy a digital twin. And a process digital twin would be based on an industry-leading simulator platform like Aspen HYSYS or Aviva Pro 2, Honeywell's Unisim, KBC's Petrosim, Schlumberger's Symmetry or Kongsberg's K-Spice. It could be steady state or dynamic. Today, I'm going to just show a steady state digital twin. And it will be integrated with key plant data that's derived from our DCS or from a data historian or enterprise data lake. Those data will be key parameters that we'd feed into a digital twin. As the process simulators have no physically representative separation modeling native to the platforms, we must embed the MySep engine model to have a fully functional production digital twin. And by adding the MySep engine, we can introduce fully physically representative models of each of the separators that are important on our system, like the first stage three-phase separator here, the low pressure suction scrubber, the high pressure suction scrubber. Each of these needs to have a fully representative model that's going to simulate the separation performance of those within the overall process simulation. And remember, here we have the low temperature separation controlling the hydrocarbon dew point of the export gas. So to evaluate the operation, we might well look at ramping up production with our digital twin. And here in the graphs, we're seeing it developed the carryover for each of the separators on the system. The inlet separator, the first stage separator, I should say, the first stage suction scrubber, the HP suction scrubber, the turbo expander inlet separator, and the low temperature separator. And here I've also graphed the hydrocarbon dew point, that quantity that's specified for the export gas leaving the compressor, the export gas compressor. So we've revealed in our digital twin why we're constrained to this level of production. And I like to call this the pre-optimized operating limit. So here we see we're pegged at this 79 million standard cubic feet per day of gas production, about 74,000 barrels a day per oil. And in terms of revenue, that's worth about $6.5 million a day to us. So that revenue and that production is being pegged by the maximum allowable hydrocarbon dew point on the export gas. Now with the MySep software, we can explore whether we can optimize the separation system. Can we fit the existing vessels with internals that allow more production? So we could look at the first stage separator, that LP suction scrubber, the HP suction scrubber, and develop, if possible, optimum internals that fit within the existing vessels to allow us to retrofit and potentially upgrade production. So focusing in a little bit on that, looking at that first stage separator, currently in terms of gas liquid separation, its internals are this vane type inlet device and what's called a vane pack demister device. We can replace that potentially with higher performance arrangement, putting in an agglomerator, and downstream of that high performance cyclonic separator demisters. So those cyclonic demisters and the agglomerator in combination can get us higher performance for this separator. And each of the separators in turn, we could look to see how we optimize the overall system. So optimizing the system, we can use again our digital twin to explore the behavior with the retrofits that we've identified. And we see here that potentially we can make the production rate independent of the hydrocarbon dew point, or should I say the hydrocarbon dew point of the export gas independent of the production rate. And that means potentially we can significantly increase production until we're constrained by some other element in the system. And indeed, here we found that we moved to a stage where we've increased the production to 82,000 barrels a day of oil and 88 million standard cubic feet per day of gas. At that level, we find we're constrained by compressor capacity and the risk of integrity of the compressor. So summarizing what we have achieved with the digital twin, using that rigorous digital twin, we found originally we're constrained at these levels of oil and gas production and a revenue of $6.5 million per day. Looking at optimizing the system and using our digital twin to prove that optimization, we can increase production to 82,000 barrels a day and 88 million standard cubic feet per day of gas, with a revenue per day of $7.8 million. So increasing the annual revenue on the facility to about $325 million. So with that, I'd like to thank you for understanding and viewing our presentation. And I'd like to ask if you have any questions about MySep and production digital twins.
Thank you, Tom, for sharing such insightful information on digital twin. It was really wonderful presentation. I would suggest all the attendees to ask the question, post the question in question and answer section or the chat option. Tom, we will wait a couple of minutes for the audience to ask the question.